Hi guys, this is going to be our application for our final product, okay? And you're going to be doing this with me, and then you're going to be doing one of your own, okay? That's just like it, but it'll be slightly different. So here's our problem. A plane is heading 30 degrees south of west, okay? Now initially on this, I did not have this, but I had to go back and look at a video here, but this is where I drew. If you look west, 30 degrees south of that would be this runway, or where the plane's heading, okay? So the plane is over here, and it's heading this direction, 30 degrees south of west, and it's going to land on the runway, okay? And then it says you have 18 knot winds blowing from 300 degrees. So if you look here, this is, remember it's 0, 90, 180's down here, 270's over here. So 300 would be 30 more degrees. Okay, so that's why I put this right here. This is a 30-degree angle here. Okay, that would be 300 degrees. So that's where it's blowing from, which means it's heading in this direction. Okay. And again, I labeled that 18 knots. Okay. In order to land safely, the crosswind component must be less than 15 knots. If not, the plane must be put into a holding pattern where it continues to circle in the air, or redirected to another nearby airport. Will this plane be able to land? What about 17 knots? So the main thing that you want to make sure you know here is the hint. The crosswind component is perpendicular to the plane or the runway. So here's the runway, right? And perpendicular means it's at a 90-degree angle, like a cross, okay? Crosswinds. So crosswinds, it would be at a 90-degree angle to the runway. So I drew it with this little dashed line right here. So this right here represents your crosswinds. Okay, this Y component, we're going to call it Y. If you form a right triangle here with your wind, so we've got this 18 knot wind, and then we have our crosswinds here, and it forms a right triangle here. X represents the headwind, okay, the wind that's blowing into the plane, I guess, toward the plane. So we've got this headwind, and we've got this crosswind that's blowing in this direction, okay? So we want to really just find the crosswinds, but we can really find both. So what we have to do is we have to use the idea here that we've got, again, this triangle. How do we know this angle right here? That's a good question. We know that this is 30. We know that from here to here, if it's 300 to 360, we know that's 60 degrees. But really the question is, how do we know this angle in here in the triangle? Well, I know that if I drew this right triangle, that this base of this triangle is parallel to the runway. So we have parallel lines right here. That means that alternate interior angles are congruent, and it also, if I know basically like that this angle right here is 30 plus 30, which is 60, if I know that that's 60, then this one right here is 60. So that's alternate interior angles right there. I don't know if you remember that from geometry, but alternate interior angles. So that's 60, therefore that's 60. And if this is 90, then this is over here is a 30-degree angle. So now I'm going to use, I can use actually either this one or this one. Doesn't really matter which one now, but I'm going to go ahead and use this one to try to figure out what my X and Y values would be. So after we've looked at the diagram, right, then we solve for x and y. So the headwind component, remember, is x. And if you look at your triangle, let's say we're going from 30 degrees, it would be opposite the 30 degrees would be x over the hypotenuse that we know is 18. So I'm going to say that again. So opposite over hypotenuse, which is sine. So remember SOHCAHTOA? So SOHCAHTOA. So I'm actually going to use sine in that case. Okay? So if I use this 30-degree angle here, then I can do opposite, so sine of 30 equals x over 18. Which means if I were to multiply both sides by x would equal 18 sine of 30. And that would be my headwind component. So now the crosswind component, and we'll figure this out in just a second. The crosswind component from 30 degrees is the y value here. Y is the adjacent, and then we know the hypotenuse. So adjacent over hypotenuse is actually cosine. So if we're doing this, cosine of 30 degrees, the adjacent side again is y over the winds would be 18 knots. And again, if I need to solve for y, I just multiply both sides by 18. And so y equals 18 cosine 30. So now to answer our question, will the plane be able to land? All right, so let's look at that value here, 18 cosine of 30. So if I put in that 18 cosine 30, and I'm putting it in right now, I'm going to get, trying to find it. As soon as you get a calculator that's working here, we can find our answer and see, again, that the goal is to see if it's less than 15 knots is what we want. And that's what they said. So 18 cosine 30, putting it in now, is, make sure you're in degrees, 15.6 basically. So 15.6, and just, even though I don't need to do the sine one, I'm just going to do it anyway. So 18 sine of 30, just so you know what your headwind would be. Wow, it's exact, it's 9. Okay, so that's telling me that our headwind is 9 knots, and our crosswind, unfortunately, is greater than 15.6 is greater than 15. So will the plane be able to land? No. The plane will not be able to land. It'll probably be put in a holding pattern until the wind dies down. But what if we did the same thing, but I just made it 17 knots? So the y component, it'll be 17 cosine 30. Okay, it would be the exact same thing, but 17. So let's see if it dies down by 1 knot. Let's try 17 cosine 30 and see if the plane will be able to land then. And sure enough, that is 14.7. So again, 14.7 is less than 15. So yes, the plane should be able to land once it dies down to 17. Okay, so you're going to do one that's very similar to this. Okay, the key is, again, remembering that your crosswind component is perpendicular to your runway, and I'll draw one out for you. But you'll have to remember that, because whatever way your runway is, so like let's say I make it go this way. If your runway is going this way, east to west, then this line, north and south, should be your crosswind component. Okay? So just remember that before you do the next one, and then I'll hopefully be able to help you with that when we have some extra time. But I hope you enjoy doing this, and we'll do another application tomorrow.